All right, now we're going to take a look at some examples now that you've had an opportunity to read the list of steps to go through. And guys, I still go through all 4 of these steps every single time I look at an organic compound. I just might get through them a little bit more quickly than you are just starting out, but I go through all 4 steps. Really, you have to follow these so that we don't make a careless mistake. Our first step asks us to find the longest continuous chain of carbons. Okay, so that's carbon bonded to carbon, bonded to carbon, bonded to carbon, bonded to carbon, and so on without any interruptions. That is going to be our parent chain. So looking at this particular example right here, maybe looking at it, you might think, okay, well, here is our longest parent chain because that's continuous, right? Well, it is continuous. However, there's only 3 carbons in that chain, and I can make a continuous chain with this compound that has 4 carbons in it. Okay, it involves going down here and creating, that would be our parent chain, what's been circled there. Now, to you, maybe this little bit here might look like it's a branch. Believe me, it's not. Okay, that's part of the chain. The reason I like to circle the parent chain is because it makes it really evident what the branches are going to be once they're not in the circle. Okay? Now, some of you might be thinking, whoa, wait, I also found a parent chain of 4, but I circled it a little bit differently, and that's fine. If you did this, that's totally okay. What we're going to end up getting is the same name of the compound, branch at the same spot, so on and so forth. So however you circled your parent chain to have 4 carbons in it is fine. So I like to just keep a little list for myself here to tell me what's going on. We've got 4 carbons in the parent chain. Therefore, the name of my parent chain, 4 carbons again, is bute. And the suffix, because there's only single bonds, is ane, so butane. Step 1 done. On to step 2, which says we need to number this chain in order to give the branches the lowest possible number. So we start numbering with the end closest to a branch. So I can start numbering at this carbon up here or this carbon down here. If I start at the bottom, I get 1, 2, 3, and 4. Okay, so my branch would be off the 3rd carbon. If I start at the top, I get 1, 2, 3, and 4. I want to have my branch with the lowest possible number, so I am going to start numbering up at this top carbon here. So that'll be 1, 2, 3, and 4. So I'm just numbering the carbons there. Maybe it's not super clear, but that's what just happened. Why do I number the carbons? Well, it's so that I can move on to step 3, which is identify the branches. Okay, so branches is, again, anything that's not a part of the parent chain. The nice thing about branches is that we name them using the exact same system of prefixes. So remember when I told you you need to pay really close attention and learn how to count to 10 using those organic prefixes? Well, here they are again. And then they'll come up again in the next lesson, and again in the one after that, and the one after that, so on and so forth. Make sure you know how to count to 10. So, here we go. Identifying our branches. Well, the first thing is we want to indicate the number of the carbon in the parent chain from that the branch originates from. So, again, just keeping my running tally. Branches, we've got 1 coming off the second carbon here. Okay, and there is 1 carbon in that branch. So that the prefix for 1 carbon is meth, and then we have now a new suffix to show that it's a branch, and the suffix is il. Y-L, pronounced il. So we haven't changed the prefix, only the suffix. Okay? That's the only branch that we have. So this example, we're going to start really easy. This has just 1 branch here on the 2nd carbon. You don't need to worry about the other information I've given you in step 3 for naming. This is it. Now, we need to put this name together. In order to do that, I have to give you a little bit of a lesson in punctuation. I've told you the general form that putting the name together follows. Okay, so the first thing that you would write is the number of the location of the branch. So again, the branch is at 2. Okay, and then you write the name of the branch name, but between numbers and that word, we're going to use a dash. So that is, I guess, the punctuation in organic chemistry. To separate numbers from words, we always use a dash. So this is 2 dash, the name of the branch is methyl. And then I'm going to write the name of the parent chain together with that as all one word. So make sure you make note of that. The name of the branch and the name of the parent chain go together as all one word, no spaces. So the name of the parent chain is butane. So this compound's name is 2-methyl butane. You'll notice I don't say the dash. I don't say 2-methyl butane. However, I have to write it, and it's just, I guess, one of the details of organic chemistry that we need to make sure that we pay attention to. All right, let's move on to the next example. Apparently, this second slide, example B, is the exact same, so hopefully you will know that the name of the compound is 2-methyl butane. So we'll move on to C. My apologies for that one. Again, guys, following through the same 4 steps. Now, if you feel like, okay, I kind of understand what's going on here, maybe you want to pause the video, okay, work through this example on your own, come back, check in with me. Maybe you want to work through this with me together. Either way, if you'd like to pause it, do so now, and I will move on. So the first thing is we have to find our longest continuous chain. Now, there's a couple of ways that I could circle this, but our longest continuous chain has 7 carbons in it. So I like to take the easy way, and I'm just going to circle straight across. Okay? I could have circled to include these 2 carbons up here. That would have given me the same length of chain, 7. Okay, and again, branch at the same number. If you don't believe me, you can take a look at it for yourself. So my parent chain, as I said, has 7 carbons in it. 7 carbons, the prefix for that is hept, and again, suffix ane. So heptane is my parent chain. Step 2 is number, and I want to number starting at the end closest to a branch. So again, this is one end that I could start at, this is another, but if we take a look at where our branches are, it's very clear that this is the end I need to start numbering at. Okay? So, numbering, and again, we just number the carbons in the parent chain. And the reason we do that is so that we can identify our branches. So taking a look. The first branch that I run across is this branch here off the 3rd carbon in the parent chain. So that's going to be a 3. There are 2 carbons in this branch, 1 and 2. And so the prefix for 2 carbons is F, and the suffix for a branch is il. 3-ethyl. Okay? So 1 branch at 3. And then my second branch is at number 4. And we've seen this branch before, 1 carbon in it, so that's going to be methyl. Now I need to put all this together. So the rule is, guys, if we have more than 1 type of branch, we need to make sure that we are listing our branches in alphabetical order. Okay, so ethyl, E comes before methyl, M, so we will list that one first. So, starting with the number of the location of the branch, a dash to separate number from word, ethyl. Now, I have to indicate that I've got a branch at number 4. Okay, again, I have a word and then a number I need to separate those from each other, and I do that with a dash. So 3-ethyl dash 4-methyl. So I've named my branches, and now I just write the name of my parent chain as all one word there. 3-ethyl 4-methyl heptane is how I would say it. Punctuation wise, I do have to remember 3 dashes in there. So I chose this example because I wanted you guys to make sure you took note of the fact that branches have to be in alphabetical order. Okay, so make sure that you've jotted that down somewhere for yourself. Let's take a look at our next example, our last example. This guy looks a little bit messy, and right now I'm thinking to myself it would have been a really great idea if I had done an answer key ahead of time so I would know the answer to this. That's okay, I'll wing it. The worst that can happen is we're wrong, right? All right, finding step 1, the longest continuous chain. I have found one with 10. Yeah, that's got to be the one. Here we go. Okay, so there we go. Now, we need to number this guy. Oh, sorry. Apologies. Let's not forget. And this step, guys, writing this down isn't necessary. Again, I said I do it because it helps me keep kind of everything in order so that at the end when I'm ready to put together the name, I just have like this list that I need to put together as opposed to remembering in my head, oh geez, what was that parent chain again? Okay, so let's number again, starting at the end closest to a branch. That's going to be this carbon right here. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Okay. All right, so let's identify our branches. So taking a look at the 4th carbon here, I have a methyl group. So at number 4, I've got a methyl. And then right next door at number 5, I have a methyl off the top. I also have a propyl. So 1, 2, 3 carbons in that chain. So I have a propyl at number 5. And then lastly, at number 6, I have another propyl. Again, that's because there are 1, 2, 3 carbons and it's a branch. Okay, so remember YL is that suffix for a branch. Prop is the prefix for 3. Put them all together. There you go. Now, we need to put this name together. So we need to remember that branches get listed in alphabetical order. The other thing that we need to take note of is that, and I believe this is step 3C in the list that I gave you guys, if more than one of the same kind of branch exists, you need to use a prefix with the alkyl name. Now these prefixes are not organic prefixes. They're more like counting prefixes maybe, or covalent prefixes. So if we have 2 of something, we would say di. If we have 3 of something, we would say tri. 4 of something would be tetra, and so on. I can't think of a time I've seen more than 4 of the same branch in a compound. So here I have 2 methyl groups, I have 2 propyl groups. Now, one other thing that doesn't come up in this example, but you guys should make note of it, is that these, what I call prefixes, the di, tri, tetra, they don't get involved in the naming or in the alphabetizing of the branch names. So if you had like a dimethyl and then just one ethyl branch, you would still list the ethyl branch first, if that makes sense. If it doesn't, come see me. I'll point out an example in your homework where that takes place. Okay? Let's deal with this example here. So, alphabetically, methyl M comes before propyl P. So, I need to indicate that I've got 2 methyl branches. And it seems a little bit redundant, but I do that 2 ways. 4, comma, 5, ooh, new punctuation, I'll get to that in a second, dash. So I've listed both the numbers where the branches are, and then I'm going to call it dimethyl. Okay, because I have 2 methyl branches. So, punctuation, when we have numbers separated from numbers, we use a comma. When I have numbers separated from words, it's a dash or a hyphen. Okay? So we've taken care of the methyl branches. Now we want to take a look at the propyl branches. Another dash because we're about to use some numbers. I've got propyl branches at 5 and 6. Why don't we use an and sign? I don't know. I think it just confuses things because this is so much less confusing. So 5 comma 6 and then a dash. Again, I have 2 propyls, so this will be dipropyl. And now is finally the time to use the name of the parent chain, all one word, decane. 4,5-dimethyl, 5,6-dipropyl decane. Easy, just like that, right? So guys, go ahead and take a look at the homework assignments. Please make sure that you are asking me if you have any questions. Good luck!